and we're at the bottom of page, I think it's 192, the order of operation page, and there's a few things we just didn't quite get done. So, all right, so let's look at this one. So here it talks about evaluating. So we need to sub in, x is a -2, so we need to sub in a -2. Now, when you sub in negatives, it's a good idea to always put in parentheses, because this is 2 minus 3. You want to square all of it, including the -2, so in that case, you have to put parentheses. So I just kind of always get in that habit, and then 2. And then we want to evaluate this. So order of operations, please excuse. So any type of parenthesis or grouping symbol. I have a parenthesis, but there's no math to doing it, but it is making that stand out. Exponents, I do have an exponent. So I have 2. Bring everything down that you don't use. And then whatever you use, replace. A -2 times a -2 is a +4. And again, you can use your calculator, but you have to be careful, because if you type in like a -2 and hit the, you know, your exponent key, I don't know, like squared, it'll give you -4 where you need parentheses to get that +4. So just be cautious with your calculator. Okay, next I'm going to multiply. So multiply and divide are tied left to right. So I'm going to get 12, and then I'm going to subtract and get a -10, and -10 divided by 2 is a -5. So, so when you have a formula you're subbing in, you're going to do order of op, and that's why we use this a lot in statistics and math for liberal arts. All right, why don't you go to the next page and try, there's some formulas there. Try those, see how it goes, and then I'll come back. So we're on page 193, and again, I want you to try these formulas, sub in the variables. Okay, so this kind of got cut off my screen, actually, so I had to truncate it. So again, if that skips the editing on this guy's not the best. All right, so let's go back and see. All right, so here's our finance formula. All right, and so we are going to do, our principal is the amount you borrow or save, so we are doing $1,000. Let me erase that. That's not looking too pretty. All right, so we have $1,000. Parentheses 1 plus. Now, your interest rate has to be in decimal form, meaning like if it's 80%, it'd have to be 0.80. So like if it was 5%, you'd have 0.05. So we have a fractional percent, which is not that unusual with housing, interest rates, things like that. You can divide 5 by 8 on a calculator and get it in decimal form. Otherwise, if you wanted to do it mentally, you could think of that as 4/8 with an 1/8. 4/8 is a half, that's 0.5. Most people know a fourth, a quarter is 0.25. So half that would be what, 0.125? So 0.625. But again, if you don't, that doesn't make sense. You just divide this. But again, this is still a percent. It's not in decimal form. I know there's decimals in the percent, but it is definitely a percent. So you still have to move the decimal over 2 jumps. So rate in decimal form, 0.03625. And then N is how often it's compounded. So it is compounded monthly, which is 12. And then your exponent is N times T. So how often it's compounded times how many years, which is 20 years. So what is that, 240? All right, so order of operations. If you have a calculator that does this, you can just type it in. If you don't, then you would get an answer to this first, because parentheses. You take this answer to the exponent next, enter, and then you would multiply by 1,000 last. So you can, if your calculator does order of op, then you can just type it straight in. Just type it in like it is. But if not, you're going to have to do this part first. Then do this second. And then do this last. And you should end up getting an answer to that one of, what, 2,062 and 48. And again, we usually round to the nearest penny. Okay, so the other ones are formulas too. This one is a statistics one. Right here, so the lower fence equals Q1 minus 1.5 times IQR. So let's see, erase a little bit and see what some of these values are. All right, so what do we have? So this is for a box plot. I don't know if you've, seen those graphs where it kind of looks like this, and maybe it goes off here and here. So that's called box plot. So Q1 is what? 60 minus 1.5 times your IQR, which is 33. So again, order of op, you'd multiply this first, okay, and get the answer to that. And then you're going to take 60 minus that. So 60 minus whatever answer you get for that. And I don't have a calculator on me at the moment. So, but then your final answer should end up being 10.5. Okay, and then the last one is a formula we use in statistics a lot as well, and this is for a z-score. So a z-score is something that helps us find probabilities. So x is your data, so 85, minus this mu symbol, that's a Greek letter, is the population or the mean, divided by the standard deviation. So there we go. All right, so order of op. Fraction bars act as grouping symbols, so it kind of groups this and kind of groups that kind of individually and kind of invisibly. So you get negative 15, divide by 15, and then you get a z-score of a -1. And my guess this is dealing with IQ scores because the average IQ is 100 with a standard deviation of 15. So that's kind of where I think that's coming from. All right, let's see if there's anything else. I think we're good. So let's go ahead and maybe start section 2.6. So turn your page to, let's see, page 197, and we'll pick up there. Okay, so again, try the Explorer on your own, see how it goes. It says, imagine that you're making a purchase at a department store and you see that there's a 10% off sale and they also have a 5% coupon. So see if the order matters. Now again, if you're like, I don't know how much it costs, you can make up any price you want. So I always like to make up $100. I think it's easy, but you can use any dollar amount you want. You have a calculator, so really it doesn't matter. And then see if the order matters. So try that and then look at letter B as well, see how that goes. Okay, I choose $100 because I just think it's easy to do the math. Now again, can you do 10% and subtract? Yeah, but that takes 2 steps. So like if I have $100 and I do 10% of it, that's $10. But then I still have to go back and subtract that $10 from 100 to get 90, the new price. So to me, that's a lot of work. It's easier to use a multiplier and say I'm keeping 90% of the value. I'm keeping 95. So if I do 90% of it first, that's a 10% discount, and then take that new answer, because that's my new price, and do my 5% discount, which means I'm keeping 95% of the value, I get this. If I do the 5% discount first, I get this price, and then if I take that price and do 10% of that, which means I'm keeping 90%. So either way, my price doesn't change. So the order in which I do the discounts does not matter, okay? And we'll talk about that in a second. The second one is if you do a 10% and a 5%, does it equal 15%? And so with percents, the only time you can really add them is like if I give someone 2% extra credit and I add it to their score. So if you think of our $100 item here, 15% would mean I only pay 85%. And notice that's $85. So it's not the same because remember, percents are a moving target. You can't add them like that. So then why do these match? Okay. So let's look at that. So grab red here. And I don't know if you guys can see the screen going like, I don't know, up brighter and darker. I'm not sure why that's happening. So if that's bothering you, I apologize. All right. So let's look at this one. So in the first one, I start out with a $100 item, and then I did my 90% first, and then I took that answer and kept 95% of that. Where the other one, I started with $100, but I did the 5% first, which means I'm keeping 95%, and then I did the 90%, or keeping 10% discount, keeping the 90% here. So if you notice on my calculator, I'm multiplying the exact same 3 numbers. And so if you're multiplying the same 3 numbers, it doesn't really matter the order. And so we have properties that kind of say we can like switch things around. If you're moving things around, that's called the commutative property, which is like commuting from Des Moines to Ankeny, Ankeny to Des Moines with a job. All right, so commuting, as long as you're only commuting adding and only commuting multiplying, it is legal. So it kind of trumps order of op. So like if you're like, well, I have to go left to right. Well, you know, you can move things if you have all addition or all multiplication so that you can maybe do things a little bit easier. So why don't you go ahead and turn to the next page and we'll pick up there. Okay, so the commutative property is going to help us a lot in algebra. But if we think in real life, it helps us too. So for example, if I give like something like 58 plus 197 plus 42, technically, according to order of op, you have all adding, you would go left to right. So I'd have to take 58 plus 197 first, get an answer, and then get 42. But I look at this and I'm like, gosh, if I put the 42 over here, I get 100. So I really want to move it. And so that my life is easier, because then this equals 100, which I can do mentally. So then I'm like, oh, I know the answer is 297. So if you want, oh boy, sorry. So if you want to move something, that is the commutative property, but you can only move it if it's all addition or all multiplication. There's no property for moving things with division or subtraction because it changes the answer. All right, so try to think about what these are here. Try number 2, and I'll come back to you in just a second. Okay, so on this first one, kind of like collecting like terms like cats with cats, dogs with dogs, you might be that they look different. But in reality, they're really the same because, sorry, all these screens are opening. Because if something is A by B, and then something else is B by A, and I can't draw very good, they're the same size, right? So maybe I need to make one a little bigger. But if it's A by B or B by A, they're just rotated. So I can commute this BA and make it AB because it's really the same shape. So I have one AB, I have another AB, so I have 2 ABs. Now, some people might be like, why didn't your exponents change? Well, because I'm adding. I'm not multiplying and creating a new unit. I'm just doing perimeter. So it's like I have something that's the length of AB and maybe another thing that has the length of AB. So AB plus AB, they don't change shape. It's like a string. It's just I have 2 ABs. Or if you think of rectangles up here, I have one AB, I have another AB. I have 2, but what shape do I have? ABs. I have rectangles that are AB. So if I were multiplying, if I had AB times AB, then I would be multiplying and creating something new. So then I'd have an A and an A, which is A squared, B and B, B squared. So when you multiply, you create new things like volume and area and all those things. Adding is just cats and dogs, collecting like terms. So in this one, it's the same idea, except it'd be AB minus AB, which is 0. Okay, and we don't usually write 0 AB because what is 0 times AB? It equals 0 anyway. So and plus, if you think of my little rectangle situation here, I have an AB, right? Well, let's go with the first guy. I have an AB, but then I take an AB away. So I'm taking this away. So then I have nothing left. I have a 0. Okay, let's look at this guy. All right, again, cats and dogs collect like terms. So I have 3x, but I owe 5x. That's negative. So I get, what, negative 2x. And then y's and y's make more y's. And so that's 12y. And again, they do not change power because I'm just adding. I am not creating a new object at all. All right. So let's, why don't you go ahead and to try problem number 3 on the bottom of this page. Okay, so here we're just using the commutative property to rewrite. So if it's x plus 2 and I wanted to commute, I could put the order around. This one, if I want to commute, this is really a negative 11. You can add the opposite if you can't see that, but that'd be a negative 11 plus 4, which, you know, I could actually get the answer if I wanted to. The next one, again, do you see how that negative is really with a 2? Otherwise, add the opposite. So that's really a negative 2 plus x. And then same thing here, the x goes with the negative, so negative x, and then plus 2, because 2 minus x, add the opposite, that x is really negative. Okay, and you can commute those. So again, I'm just moving the order. All right, we're going to stop there.